In this problem, we're trying to find the mass of sodium chloride and the number of units that could be made when we have a certain amount of chlorine gas reacting with sodium metal. So to start, we need to have the balanced chemical equation. So for the chemical equation, we have sodium metal. So we're going to put a solid for its phase, and it's being combined with chlorine gas. Now the formula for chlorine is Cl2 because it's a diatomic element, and it's combining to make sodium chloride. Now at this point, we have more total atoms in the reactants than we do in the products. This equation's unbalanced. So to fix that, we notice that we have 2 chlorine atoms as reactant, so we're going to need to have 2 chlorine atoms in the product. In addition, that changes the amount of sodiums we have, so to have 2 in the products, which means we need 2 in the reactants as well. Step 2 is we're going to fill out the remaining cells with the information that's given to us in the problem. Up here, it tells us that we have 25.71 grams of chlorine for us to use in our reaction. So we're going to put 25.71 grams into the cell for chlorine gas. Step 3, we're going to find the formula masses of all of our reactants and all of our products and put them into the first row. For sodium, it's going to be 22.99 grams per mole. Now, in this case, we're ignoring the coefficient in front because we want just the mass of the formula, and in this case, a single sodium atom is the formula. For chlorine, on the other hand, we have 35.45 for chlorine. However, there's 2 of those atoms in the formula to give us a mass of 70.90 grams per mole. Our last one, we're going to have the mass of the sodium atom and the mass of the chlorine atom combined together, and again we're ignoring the coefficient because that does not play a role into the formula mass. At this point, we can use the information given to us, such as the mass of chlorine gas, as well as the formula masses, to figure out the number of moles of any of the amounts given to us. So in this case, we have 25.71 grams of chlorine gas, and we can turn that into moles using the formula mass. So 1 mole of chlorine gas, 70.90 grams. When we do that calculation, we find that we have 0.3626 moles of chlorine gas available. For step 5, we're going to use the mole ratios, which are the coefficients up in our balanced equation, as well as the moles available, to find the remaining moles for all of the other chemicals used in this reaction. So in this case, we're going to start with the 0.3626 moles of chlorine gas. And from our mole ratio up here, we have 2 moles of sodium for every 1 mole of chlorine, which means we're going to have a doubled amount in this box, which gives us 0.7252 moles of sodium needed for the reaction. In addition, we can go over to sodium chloride, and it's the same 2-to-1 ratio. So we're going to have 0.7252 moles of sodium chloride produced. For step 6, we're going to use the mole values we just calculated, as well as the formula masses from earlier, to find the mass of sodium needed for the reaction, as well as the mass of sodium chloride produced in this reaction. So to start, for the sodium, we had 0.7252 moles needed from our calculation, and using the formula mass, we can convert that to mass because it's 22.99 grams per mole. When we do that calculation, we find that for this reaction, we are going to need 16.67 grams of sodium. When we take that mass of sodium and react it with that mass of chlorine given to us in the problem, we should find the total mass of the products to be the same. So to check that, we will have our 0.7252 moles of sodium chloride, and using the formula mass again, 58.44 grams per mole in this case, and that works out to 42.38 grams of sodium chloride produced. If we check our work, we can find that 25.71 grams of chlorine in our reactants added to the 16.67 grams of sodium comes out to the same 42.38 grams of sodium chloride, showing that the law of conservation of mass again holds up here. It's a good way for us to check our work. For step 7, we're going to use the moles we calculated earlier, as well as Avogadro's number, which is 6.022 times 10 to the 23rd things per mole, in order to convert from moles into the number of particles for each of the reactants and the products. So to start, for the sodium, we have 0.7252 moles of sodium atoms, and to figure out the number of atoms that is, we're going to multiply it by Avogadro's number. When we do that calculation, we find that for this reaction, we have 4.367 times 10 to the 23rd atoms of sodium. We can continue that same calculation for the rest of our cells, and we should find that we have 2.184 times 10 to the 23rd molecules of chlorine gas, and we also have 4.367 times 10 to the 23rd formula units of sodium chloride. Once you go through these 7 steps, you should move on to step 8, which is to go back and check your work. Make sure that the law of conservation of mass held true and that the total mass of your reactants was equal to the total mass of your products, like we did earlier in this case. Also go back and make sure that you have the correct units on all of your numbers, as well as the rounding using the appropriate number of significant figures.